In this summary, which will address Chapter 7, we will be looking at managing the costs that have been allocated to the project. And this process will refer back to the baseline plan, but will also introduce new tools and techniques to allow us to determine if our cost and performance on the project are tracking as we would expect them during the duration of the project. That's key. We want to be able to track our costs over the duration of the project in order to make sure that we're not getting into trouble along the way. We will begin by looking at the really big picture. So, keep in mind, cost planning and budgeting begin at the very, very earliest stages of the project. Recall the project life cycle diagram that we talked about in the very first presentations in this class. We indicated that the early stages are critical. Now, on that graph, it makes it look like they're not as important because they're lower on the graph. But remember, the vertical axis on that graph is effort, not importance. The importance of those early activities is key because that's where the planning and the budgeting begin. So it begins all the way at the proposal stage. Now, what are we talking about when we say costs? We're talking holistically. So labor, materials, subcontractors, equipment, perhaps permitting, perhaps facility rental if you have travel involved on the project, preparation for presentations, preparation for publications. All of these things cost money. And everything that costs money needs to be factored into the budget of the project. It's the little things that can add up quickly and cause budget overruns. The two big steps in this process are discussed here at the bottom of the slide. The first step is once we have this idea of what all is involved in the project, we need to allocate out the budget to the various work packages. You can almost substitute activities for work packages, but work packages can maybe be a bit larger. They can include multiple activities. So for instance, you might have a work package that is entitled Document and Publish the Results of the Research. But there might be several activities inside there: the writing of the document, the proofreading of the document, the typesetting of the document and finalization of it for publication, the mailing and shipping of the publications to the publisher. So the work package can be a little bit larger. It doesn't have to be. The work package can be at the same level as the activity. It depends upon how the budgets are performed. Keep in mind, however, there's typically lots of activities, however, on a project. A larger project may have hundreds of activities in the network diagram, and often the budget isn't broken down to quite that level of granularity. So the first activity, or first task, the first step, is to allocate the budget out to the work packets or activities. What this means is you need to know how much each portion of the network diagram is going to cost, what it should cost according to the baseline plan. Then we get to the second step. The second step is that we then distribute that cost out over time. Now let's think about that for a second. Let's say we have an activity on the network diagram that's going to take 15 days to complete, and it's going to cost $15,000 to do, according to the baseline plan. 15 days, $15,000. Now, what we have to ask ourselves is that, can we assume that that money is evenly spent? So 15 days, $15,000, is that $1,000 a day? Or is there going to be $10,000 spent in the first 2 days and then much less spent in the next 13 days? We need to have that distribution of the work over the activities, over the work packets, financially speaking, the distribution of the money and the work over the activity, in order to be able to tell if we're tracking right with time. Remember that when we collect actual data, we're going to collect data at a snapshot, and that snapshot may be halfway through an activity, and we have to know how much money we should have spent up to that point. We will now talk a bit more in detail about this first step, allocating the total budgeted cost to the work packets or the activities. Okay, allocating that total budgeted cost to the work package will establish a TBC for that work package. Okay, so that is the total amount of money. You're taking the big budget, imagine the big sum of money for the entire project, and you're cutting that big sum of money up into an allocated portion for a segment of the work. And we're going to call that segment of the work a work package. That could include only one activity. It could include maybe a few activities. Once done, that allocated amount establishes a total budgeted cost, TBC, for that work package. As it states on this last bullet, the budget for that work cannot exceed the TBC or you're in trouble. You are now going to run out of funds, you're going to have issues satisfying the customer, you're going to have issues meeting schedule or deliverables. So this kind of defines a hard limit of how much money is available. Now there's two ways to do this process of allocating the money out to the work packages. You have this kind of big sum. The worst thing you can do is kind of a top-down approach. The worst thing you can say is, well, I have $10,000. I have 5 work packages, so therefore each work package gets $2,000 because that's what we've got available, divide it up and we're done. The problem with that approach is, while that may get you to allocated amounts that are within the total budget, it's not realistic. There's no reason to expect that the work can actually get done in that work package for the amount of money you allocated. Instead, what you really need to do is what I consider kind of a bottom-up approach. You need to stand back and say, what is it going to take to do this work? And build that allocated amount up from the actual work that's going to be done. Once you know that amount, then that's the amount that is needed to do the work to the quality and to the schedule required for the project. This emphasizes again why this entire process begins at the very earliest stages of the overall project. Way back when you're writing the contract, when you're turning in the proposal for the project, you need to be looking at budgets. Because if you wait until after you know what your budget is and the money's already set, and then decide, well, how much can I afford to spend on each work packet, you're setting yourself up for failure. You need to work it the other way around. So this process of budget allocation is holistic. It goes from day 0 to the end of the project. It does not begin halfway through the project. I cannot overemphasize that. The second step in this process that we discussed briefly earlier is to distribute that money across the work package with time in order to determine what's known as the cumulative budgeted cost. The cumulative budgeted cost will be a graph, okay? It is not a number. The CBC is a graph that changes with time, and it shows how the money will be spent during the execution of the work package. So you may burn at an even linear rate. You may burn very quickly and then the expenditure slow, or you may start out with very few expenses, but then near the end of that work package, as you bring things to a close, there's large amounts of money that must be spent to reach that conclusion state. So the CBC is important, this cumulative budgeted package, or cumulative budgeted cost, sorry. this is critical because we're going to use this as our comparison, as stated in the last bullet here, to the actual cost data that we collect during execution of the project. This is going to be one of our key control metrics. Without this, collecting the data won't tell us a whole lot. Now, the CBC alone is not everything we need, as you're going to see in the next couple of slides. There's more to it than just the CBC, but the CBC is critical. So distributing across the work package, the allocated budget. I would encourage you also, it's not on this slide, but I would encourage you to be very cautious as to who is involved in helping you make those decisions. You need a person helping you distribute those funds that is knowledgeable of the actual work. If you're not the one that's going to be doing the actual work, you're probably not the right one to make those determinations. You need to be working with your team and working with those that will be executing the activities in the work package. Let's then talk about how we will do the actual cost performance analysis. This is a key portion of our overall budget control activities. First of all, we need to talk about several definitions. These acronyms are used a lot in the textbook, and so therefore we will want to get comfortable with them. Some we've already introduced. We've talked about the TBC, total budgeted cost, for each work package. We've talked about the CBC, the cumulative budgeted cost, and that would be the amount spent during the execution of the work package, so it changes with time. We also have the CAC, that's the cumulative actual cost. So not budgeted, but actual. So if we were to go out and talk to our team that's working in a particular work package on a daily basis and monitor how much they're spending, that would be the actual cost. Now, we might not do that on a daily basis. That may be too much data. We may pick reporting periods that are a little bit less frequent. But that's the idea of actual. So CBC is the plan. CAC is reality. We also have the EV. That's the earned value. This can be a little bit difficult to wrap your mind around, and it's also very difficult to estimate at times. But let's say that we spend $1,000 on a particular activity. The question is, was that $1,000 expenditure worth $1,000 in value? In other words, let me explain it this way. This might be a better way to look at it. Let's say an activity costs $10,000. Let's keep the math easy, $10,000. And let's say we've spent $2,000 so far. Or the budget says that we've spent $2,000 so far on that particular activity. So we've spent $2,000 out of $10,000. So we've spent 20% of the money. $2,000 out of $10,000. Now, have we completed 20% of the work? Have we solidified, have we earned 20% of the value associated with that activity? Or are we spending money on things that don't really matter? So we're spending the money, but we're not accomplishing the task. In other words, that's what EV is about. It's, are we accomplishing the task at the same pace that we're spending the money? So EV is the earned value up to any instant in time. So if I go and ask my team, what is the EV right now? They would say, well, 20%. Okay. Cumulative earned value grows with time. So if on Monday I go and ask them, okay, how much have you done? They say, we've earned 20% of the value. I go back on Tuesday, they say, well, now 30%. I go back on Wednesday, they say, well, now 38%. The cumulative EV turns into a plot. It's how the earned value grows with time as we progress through the project. So we have the EV and the CEV. We have the total budgeted cost, the cumulative budgeted cost, and the cumulative actual cost. kind of memorize those acronyms because we're going to be using those down below and in subsequent slides. Now, how do we use these to make a numeric or quantitative determination of how our project is proceeding? There are two primary ways of doing this that the book discusses. Each is good. They are just two different metrics that kind of measure things a little bit differently, but they're both valid. The first is called the CPI, Cost Performance Index. Very common. The CPI is equal to, or you calculate it by taking the cumulative earned value, the CEV, and dividing it by the cumulative actual cost, the CAC. Are you earning value? Are you accomplishing value at a rate equal to or better than what you're spending? So you want this to be equal to or greater than 1. Greater than 1 is good. Equal to 1 is exactly on plan. Less than 1 means that you're spending more money than you're actually accomplishing value, which is a danger sign. So the CPI needs to be 1 or greater, CEV divided by CAC. A counter metric that is also often used is called the cost variance, the CV. The cost variance is the cumulative earned value minus the cumulative actual cost. So CEV minus CAC. You're using the same two items in both of these, cumulative earned value, cumulative actual cost. It's whether you form them into a ratio and set that equal to 1 or better for positive performance, or do you determine the difference, CEV minus CAC, and you want that to be greater than 0. If it's less than 0, then that means you're in trouble. Really, they're telling you the exact same information. One is simply a ratio, so it's more of a percentage metric, where the other one is more of a literal. CPI is more percentage, CV is more actual dollars. What's the difference in dollars? Both are good. Different companies and different organizations will gravitate towards one or the other. So these terms are very important, and you'll want to make sure you're understanding what these are as we move forward. Now, one more thing I want to talk about before we look at an example is the idea of cost forecasting. This can be a little dangerous. Anytime you're doing forecasting, you need to be cautious, because what you're doing is you're using past information in order to try to predict the future. And we all know that fortune telling is not a valid ability. You can try, but things can change. And therefore, any prediction of the future is highly, highly suspect. In mathematical terms, what we're doing is extrapolating. We're using the past to extrapolate to the future. Extrapolation is always a risky business, but at times it is necessary. And so what we're going to do is we're going to look at what's termed the forecasted cost at completion, the FCAC. What this metric tells you is, based on the past, how much will we end up spending by the time we get to the end of the project? If things continue to go exactly as they have been going, where will we end up at the end of the project? Now keep in mind, that doesn't mean things will continue exactly the way they have been going. Things can get better, but things can also get worse. However, FCAC is still used. There are 3 ways to predict this. Some are easier, some are more challenging. They are not going to give exactly the same number. That's what's really kind of weird about this. The FCAC, it's a bit of a guessing game, and so how you do that guess is a little bit different. But these are the 3 most common ways. The easiest is to take the total budgeted cost, the TBC, and divide it by the CPI, the Cost Performance Index. We talked about that on the prior slide. Remember, the Cost Performance Index is basically a ratio. It's telling us how we're progressing to date. And so if we take the total budgeted cost of the project, the TBC, which is for the entire project, divide it by that CPI, it'll tell us where we end up. If the CPI is exactly 1, which means you're exactly tracking according to the plan, then TBC divided by 1 is just TBC, and you're going to spend the full amount of the money on the project. If you're doing better than expected and the CPI is greater than 1, when you divide the TBC by more than 1, then honestly you're going to underspend on the project, which is a great thing. And so you can see how that mathematically works. That first equation is a very common way of doing it. The second equation is you take the cumulative actual cost, and then so that's how much you spent to date. That's how much you spent to date, plus how much you think you're going to have to spend in the future. So you take what you spent so far and add on to it what you're going to need to spend in the future. To estimate how much you will need to spend in the future, you take the total budgeted cost and subtract off of it the cumulative earned value to date. So you've already done that much of the earned value. If you subtract off that, it'll tell you how much earned value is left that you still have to do, and you add that on to the cumulative actual cost to get the FCAC. Again, just a different way of predicting that future expenditure. The last one is kind of less mathematical, more you're trusting the expertise of yourself and your team. So what you do is you take the cumulative actual cost, that's how much you've spent to date, and then you basically go back out to the team and say, well, let's re-estimate how much it's going to cost in order to do the remaining work. So you form a re-estimated metric of that work. That can be good if situations have changed or if situations are changing and you need to factor that in. In other words, the past isn't a good prediction of the future because things are changing. The first two equations, you're using the past to predict the future, which may or may not be a valid thing under all circumstances. The book will talk about these more. These are all important to know. Just be aware of how risky this can be. Going into your manager, your supervisor, and telling them this is what we're going to spend by the end of the project, I guarantee this, you can't. You can't guarantee it because these are only extrapolated predictions. They are not known facts. We're now going to look at an example. And before we do that, I'm going to remind you of the process of cost control. What we're going to do is collect data on a regular and timely basis. Because of that, you will see in this example, we're going to be plotting things with time, showing multiple collection periods. That's how it needs to be done when you're actually executing a project. So you haven't seen this quite yet. We've talked about the need for multiple collection periods and the need to go through that control flowchart multiple times. Now we're going to actually see that happen in the data. What we're going to do at each step is identify cost differences. If we are performing well, great. If we're not performing well, then we need to think about what are we going to do to make a corrective action. And so we're going to have to look at this data at a work package level, activity level, and decide what corrective steps are needed. That could be changing how we're executing the work package. It could be maybe revising the plan, because maybe the plan was faulty in the first place or something was missed. I mean, mistakes happen. And so when that is identified, it's better to take corrective actions and admit the mistake than to just ignore it and let the damage continue. So keep this process in mind as we look at the example. This slide shows the example at an extraordinarily high level. It's a very simple example, but it will be sufficient to help us understand how this process works and to not get lost in the numbers and lost in the process. At the top, you see the network diagram. The network diagram has only 3 work packages, or activities in this case. We have the design work package, we have the build work package, and we have the install and test work package. In reality, there would probably be sub-activities in each one of those areas if we were going to really execute this project because those are pretty high level. But for now, in this example, we're just going to look at them at that level. So you can basically consider them work packages or activities, either one. It won't change anything in this particular project. Okay, so you'll see the duration here. The design has a duration of 4, build has a duration of 6, install and test has a duration of 2. At the lower portion of this slide, you will see how much money we have for the project and how that money has been allocated. So they've already completed that first step that we talked about 5 or 6 slides ago. They've taken the total budgeted cost, the TBC, and they've allocated it out to the work packages. $24,000 for the design package, $60,000 for the build package, and $16,000 for the install and test package. Again, those have to add up to the total cost on the project, but you need to make sure they're realistic. You need to really build those numbers from the bottom up and not from the top down in order to know that they're realistic estimates of the cost necessary for that work package. We're now going to look at multiple plots. These plots will be superimposed on top of each other to help us interpret them. And we're going to be systematically adding information to our investigation. First of all, let's begin with just the plan. You'll notice that we have a table on the left-hand side that shows the overall duration of the project. These work packages must be done sequentially, and so therefore things flow exactly as shown here. We have 4 weeks for design, we have 6 weeks for build, and then we have 2 weeks for install and test. We have also in this graphic performed the second step that we talked about 5 or 6 slides ago, where we've distributed the allocated budget for the work package. Initially, we allocate a portion of the TBC to the work package. So let's look at design. We took $24,000 of the $100,000 for the project and allocated it to design. Now we're distributing that money, and we're distributing it unevenly. $4,000 in week 1, $4,000 in week 2, $8,000 in week 3, $8,000 in week 4. That adds to the $24,000 because we can't go over the TBC of that work package, but we can distribute it in an uneven way if we know that's how the work is going to be executed. And we need to do that if at all possible. If we don't, then we're going to have all types of alarms going off during our control process as we track, because we're going to see that money is not being spent at the right pace. We need to have an estimate of the pace at which the money should be spent. So, focus just a little bit longer on the table on the left. You will see at the very bottom the cumulative. This is basically the CBC in numerical form. The bold row at the bottom is the cumulative budgeted cost. In week 1, we've spent $4,000 total on the project. Week 2, we've spent $8,000 because we take what we spent in week 1 and add to it what we spent in week 2. So the cumulative budgeted cost is always increasing. It never goes down. It's a growing plot that should, ideally in the end at the total cost of the project or less. And you will see it there. On the right-hand side, you'll see the plot of that bold line at the bottom. So the CBC for the project is shown on the right-hand side. And you'll notice it's not exactly a straight line because of the fact that the money is not distributed exactly evenly within each work package. Okay, once we have the plan in place, we can start our control process of actually monitoring performance within the project. And so now we have, through week 8, shown here, actual data that we've collected on performing the project. So you'll notice in week 1, the actual amount of money spent was $2,000, but if you recall back to the earlier slide, $4,000 was budgeted during week 1. In week 2, we spent 5 more, so we have a total cumulative actual, CAC, of 7 at the end of week 2, but our CBC, cumulative budgeted, was 8. So you'll notice over here, let me highlight this, early on, we're actually performing better than expected. The cumulative actual cost is below the cumulative budgeted cost. But then time keeps going. So in this stage here, things come back more into alignment. And then all of a sudden at around week 5, we start spending at a higher rate than what we had planned. By the time we get to week 8, we have spent $4,000 more on the project than what we should have spent by that time in execution of the project. Now, this graph could turn back down and come back into alignment. It could even come back down and go below. Again, this does not mean that we're going to end in a disaster, but it means we're on a path to end in a disaster, and we need to be taking corrective steps. That is the entire purpose of doing this budgetary control on a timely, periodic basis, to track things in time to allow you to take corrective steps before it is too late to take those corrective steps. The prior graph, in and of itself, would have indicated we have a slight potential problem. We are a little bit overspent at the end of week 8, but only $4,000 overspent out of a total budgeted cost for the project of $100,000. So in the big picture, that's a 4% overspend, and we still have 4 weeks left to try to take corrective steps. So the plot on the prior slide by itself, if we had just stopped there, it's not good news, but it's not horrible news. It's not terrible. Now we're going to add the earned value picture to this. You really can't just stop at the CAC. You need to have the earned value as well. Now, shown here on the left-hand side are the cumulative earned value numbers for the actual project. Okay? Cumulative earned value. Now, up at the top, you will see how things kind of are progressing. So this one here, 10% during week 1, 25% during week 2, 80% complete by week 3, 90% by week 4, and then this was only a 4-week duration project, the design. So as of week 5 on, it should be at 100%. All the money should be spent, but all the value should be earned, okay? So down here we have the actual of how things are going, okay? And so we have what happened in week 1. This is the estimate of how much earned value, earned value, earned value, earned value on out, okay? So we see what's happening within the project. Now, this is what's a little disturbing. When we actually plot this, you now notice that the earned value is below what we've spent on the project, and even below what we've budgeted on the project. So what is really happening is we are spending money at a rate faster than expected, and we're accomplishing work at a rate slower than expected. And so that's a double negative. Not only are we spending too fast, but we're basically accomplishing too slow, which means now there is a potential significant issue here on this project. And we need to take corrective steps if we're going to have any opportunity to correct things in the 4 weeks available before termination of the project. This last slide summarizes the example in a more simple form, kind of getting away from the cumulative plots that can be a little more confusing to interpret due to the fact that they keep changing with time as we progress out. And this takes a snapshot as of the end of week 8 where we're at. So what this is saying is at this time we should have spent, this is what should have spent, this was been budgeted, we should have spent 64% of the money by the end of week 8. We have actually spent 68%, which that's a relative minor difference, but we've only completed 54% of the work. So we are 10% behind on completing the work, 54 to 64, and we're 4% ahead on spending. The fact that this is higher and this is lower is a very bad sign. And so as we start tracking these things, as you start tracking these things on your projects, be aware that these two items together show you the picture as to how the project is really progressing. Individually, they are indicators, but they are not enough. It's really dangerous to just look at the CAC or to just look at the CEV. You need to look at both in order to see if things are moving in opposite directions or trends are occurring. That will finish up our summary of Chapter 7. Now, it's important that you read through Chapter 7. The book is going to add a lot more detail, but ideally this gives you the big picture of what we're attempting to accomplish and will help you focus your attention as you read.